Okay, here we go with the properties of exponential functions. We're going to look at y equals 2 to the x, y equals half to the x, and y equals 3 times 2 to the x. So if we go to 2 to the x, remember, first of all, remember that everything is all about y equals a times b to the x, where a is your initial value. So this is your initial value. It's also your intercept, your y-intercept. And the way that works is if we're going to graph something in like this in just the positive coordinates here in quadrant one, what you have is something like that for exponential growth. You start off here and you grow like this. This is what you start with. And this is, if we look at the Cartesian plane here, this is going to then be your y-intercept. Okay, so that's your y-intercept here. So your y-intercept is your initial value or your a, or if you think of it this way, it's when x equals 0. So when x equals 0, that's when you're on the y-axis here in your y-intercept, and a lot of times we'll see what that is. B is your growth rate, so or your ratio. It's either growth rate or it's your decay rate, and we'll figure out how to get that quickly too. So quick table values: 2 to the x. I like to start at the bottom here. 2 to the 2 squared is 4. 2 to the 1 is 2. 2 to the 0 is 1. 2 to the negative 1 is 1 over 2. And 2 to the negative 2 is 1 over 2 squared, or 1/4. So those are my points here. And then we're going to look at what that looks like. If I was to sketch that, I would have something that would grow. So here I would have something that would be like this. I start my intercept at 1. So this point here is at 1. Then I go to 2, then I go to 4, and then I flatten out here. Okay, so it looks like this. Key part, or it doesn't look like that. It connects the dots. And the key things are that my a is 1. And if you look here, there's nothing multiplying by the 2x. So here I had b to the x times something. My b is going to be my 2 here. But my a is what's in front here. And if nothing's there, it's assumed to be 1. Now, another way to get b from the table of values is to get the first differences here, and then see the ratio of the first differences. So from here to here, I have to add a quarter, sorry. To go from a half to 1, I add a half. From 1 to 2, I add 1. From 2 to 4, I add 2. And the ratio, how do I get here multiplying now? To go from a half to 1, I have to multiply by 2. To go from 1 to 2, I have to multiply by 2. And this 2 is this 2, which is this 2, which is my b. Okay, so that's my growth rate. My domain and range, I got these backwards. Domain, first, range. Domain for all of these is going to be x equals r. X is a real number. Okay, so I'll just give you that right now. There's no limit on that. My range is going to be based on a couple of things. One, my asymptote here is 0. Okay, I have a y equals 0 asymptote, and I need to be greater than 0. Not equal to, but greater than 0. I never get to 0. When I look at this now, let's do this one in green. That's the bell. If I look at this one, 1/2 to the x, 1/2 squared is a quarter. 1/2 to the 1 is a half. 1/2 to the 0 is 1. 1/2 to the negative 1, you got to flip that to make it 2. 1/2 to the negative 2 is 2 squared, which is 4. And you realize that these go together. 4 goes with 4, 2 and 2. 1 stays there, and keep going. You plot this, and it looks exactly like this, and it's a flip here, a reflection in the x-axis. One way this should make sense is a reflection in the x-axis. In the old, what we used to say was a reflection in the in the y-axis is a horizontal reflection. Horizontal reflection means you want a negative on your x value here. Okay, so that's when we talked about AK and DC. And reflected like that, you're going to have a negative right on the x. Well, this is the same, 2 to the negative x. If I said, what's that? That's the same as saying 1/2 to the positive x, or just 1/2 all to the positive x. Okay, and that's this. So that's why these are reflections of each other. A again is 1. Okay, I have nothing in front here, or my initial value is 1, or this is 1. They're all the same. B is what I'm multiplying by here, which is a half. If you want to go through and do this, find out what the ratio is, the common ratio, you can. First differences, and then the ratio. I go from here to here, I multiply by a half each time, and now I also have y greater than 0. And y is a real number. I should add that also. Okay. If I have something like this, 2 to the x, we're going to just take it a step further. And actually, let's take a little break from graphing and go to Desmos. I have 2 to the x, and I've changed half to the x as 0.5 to the x, and they look like this. Okay, so just quickly what they look like. Again, key points here. Oh, the lights just flashed. Anyway, you can't see that. So that's what that looks like. Intercept of 1. This guy grows. This one decays. Again, this is increasing. Oh, another thing I could ask you is, are they increasing or decreasing? We read left to right. So we're going this way. This guy is getting bigger. This guy is getting smaller. Increase, decrease. Asymptote at 0. Always bigger as my range. Always bigger as my range. If this was a negative, if I had a negative number in front of this whole thing, so what I'm going to do is I'm going to show you what this guy looks like. This is the one I'm graphing. You can work 3 times 2 to the x. Difference here it is going to be, I'm going to have an intercept of 3 here. So my intercept is going to be 3. So that's the one I'm going to graph. But if it was negative, you'll see this also. If it's negative, then I come down here, and I'm going to have a range of y has to be less than 0. Anyway, we're not going to do that one in this video. So back here, I have y is equal to 3 times 2 to the x, and I look like this. And let's go and see if we can figure out how we get those points. Starting at the bottom here, 2 times 2 is 4. 2 squared is 4 times, so 2 squared is 4 times 3 is 12. 2 squared is, 2 to the 1 is just 2 times 3 is 6. 2 to the 0 is 1 times 3 is 3. 2 to the negative 1 is a half times 3 is 3 halves. 2 to the negative 2 is a quarter times 3 is 3 quarters. So if I was to sketch this, I would have the point 0, 3. So this was 0, 1, so I'm up here. And then the point 1, 6, which is up here, and then 2, 12, which is way up here. And then it comes down like this and does this. Okay, so this guy here. And then I keep coming, negative 1 is 3 halves, which is over here somewhere. And again, I have an asymptote as I will approach 0, but I never get to 0, so I have an asymptote of 0. And y is always greater than 0 here. And then you go through these things to figure out what's going on. Well, this is a little more straightforward. There's y, a, b to the x. Okay, so a is 3. So a is 3. A is also 3 because my intercept is 3, or my initial value of when x is 0. I have y is 3. And then my b is 2. That's 2. And if that's true, is that true? Well, if I get my first differences, that's 3, and that's 6. And how do you go from here to here? 6 divided by 3 is 2. And if you do that with all these, which is a little difficult with fractions, you would find that b is also 2. Okay, so that's the general properties of exponential functions, and there's a little section there in the textbook that goes over what happens with when a is this and b is that and that sort of thing. This is growth, this is decay, this is growth also. Anytime your b, is bigger than 1, it's going to grow, it's going to get bigger. Anytime it's smaller, it's going to get smaller. And if you look at Desmos to prove it, you can, let's get rid of all these here. Anytime you have anything here, I can't get rid of this. If this is bigger than 1, so 5 or 8 or 1.02, anything. See, that's growing. It's hard to see, but it is growing. And these, let's look at this for a second. So if we just have to change our perspective here, and it is growing, and if I kept going further and further out, I would see that it does grow. This, if I go to 09, something like that, anything bigger than 1 will grow. Anything smaller than 1 will decay. Even 0.9999999, that's coming down. You can't tell. Anyway, 0.9 comes down like that. Okay, so decay. And then if you put a number in front of it, it's going to change the intercept. So there's 5. My intercept should be 5 now. And I go over here, and that's 5. Okay, decay with an intercept of 5. This is my A. This is my B. A is my intercept. B is my growth rate or decay rate. Okay, hope that made sense. Take care.